Good afternoon, everyone. Thanks for joining. So I will start with kind of the introduction. What are the LLMs? How we can use that, and then we will go to the kind of the second phase that I've prepared a kind of example, hard-coded, hands-on practice that we can see that how we can do the LLM in action. So I will kind of provide the codes after as well. Whenever you want to kind of try it on your end, you can have it. So to be honest, 2010, I started as a developer. The first language that I've learned was Visual Basic. And then I I was starting my instructing as this kind of a junior teacher in an institute there as well. It's going to be 10 years, 12 years that I'm teaching as well over the weekend. I started with Visual Basic, Pascal, C#, .NET, and my main kind of domain those days was kind of back-end engineering and back-end development of the web applications. Then I switched to data engineering. I found it more excited later because I could find the numbers, dashboards, analytics, trends. Then I kind of got a position in a data scientist in a company here. We call it Avenue Living. Asset management. I was a data scientist there, and now I'm a data operations manager. So it's less than a year that I'm a kind of a supervision of the data operations and engineers and software engineers that we have there. I got my master's in U of C. It was related to kind of pattern recognition. I used lots of those days LLM was not this much trend, but I used kind of the time series applications and time series algorithm to do that. So let's start with the rise of large language models. AI and NLP evolution happened, and we knew that we need to have the chatbots, we need to have an assistant, we need to have someone that be a co-pilot of us in our day-to-day works that we have. But when we had NLP at first, it was so difficult that what we have now on LLMs. On the NLP approaches, we had kind of a teacher of the literacy. We have to know that what's the part of the speech, where is verb, where is subject, where is adverb, and we should have a rule-based kind of bots to act like a human. But after having the evolution of the LLMs, and the pioneer was the kind of GPT-1, GPT-2, they started to let us know that now we can change things and we can rely on the chatbots that powered by LLMs, large language models. The good thing about large language models are those are kind of deep neural networks that based on the different practices, bunches of training and practices that they have on the training data set, they learn how to act like a human and talk like a human. So kind of now enterprises trying to use the LLMs as much as we can. They want to put the touch of AI, but just adding the LLM chatbot to their projects. And it works sometimes, sometimes not. But we could say that it's not just if you add a chatbot to enterprise project, now it has an AI. I would believe that other than LLM, we need to have on top of that hybrid models that can have a decision making on the situation that you need to have a decision, you need to have kind of think like a human and act like a human. But we have time to go there. When the enterprises kind of adopted LLMs, now they need to scale them because we know that the number of requests that they are getting out of the whatever related LLM applications that they are creating is going further and further. More requests, more people try to test that. So bigger models, bigger impact. And we need to kind of be sure that we are scaling them correctly, because easily you can lose your customers by just not make the scales available for everyone. For LLM scaling, it's more about kind of you design the automation for that. You have to have kind of a big picture that what you want to do when you have your model ready, how you want to scale it. Do you want to bring it on the cloud? Do you have on-premises kind of solutions that you want to do that? based on each of the decisions that you have to make a kind of proactive decision on that. One of the good examples of the scaling of projects of LLM is you need to be sure that you are cutting costs as well, because you cannot just having vertical scales, adding as much as processors, as much as memories that you want to your model or to your infrastructure of the model that it provides, and be happy that we are scaling our project. We need to know that if we are doing it horizontally or vertically, and when should we do that? When should we decide to have vertical or horizontal or even hybrid version of that? So as we know, LLMs are in action now. Chatbots are getting better and better. We have 24/7 available kind of customer support. It helps all the enterprises to kind of rely on the chatbot. They can kind of keep their records of what's going on between their customers, with the customer care that they have. So it's very important that now we have this chatbot, but we need to be sure that they are reliable. Even the auto summarization, kind of contract analysis and legal insights are one of the good examples of using large language models, because we shouldn't forget that large language model is not the whole brain of a human being. It's just mimicking the part of talking like a human or texting like a human. It generates the language like a human, but not all the decision that it takes, it's not like having a reasoning correctly behind that, because easily you can make a hallucination out of an LLM. If there's no fact behind that, LLM can simulate a fact and then rely on that fact and answer you back. There are lots of bunches of kind of samples that you can see on YouTube that people are trying to crack it, jailbreak the LLMs, and then asking things that are not facts. Even you can ask that, I need an article talking about something very weird, and it simulates there is a fact and there is an article behind that. So guardrails are very important. You can find it faster by AI enhanced search and knowledge management. As much as we go further, we can retrieve the knowledge that we have in the organization and getting well organized by the LLMs, because they can read, they can ingest, they can kind of document it very well. So we can find it faster with LLMs. The other good thing, actually business win, is fraud detection in finances. Because most of the time, fraud detection is someone, a human, kind of part of a fintech, mostly companies, they need to do the fact check. Fact checks are all in the documents. They can check that if anything that is going on that transaction makes sense or not. If yes, if no, and what kind of confidence score it has. So fraud detection got better. Patient insights in the healthcare. Although that in the healthcare we need to have more and more guardrails, because there are sensitive information there, but patient insights got better, well organized by the LLMs as well. We can kind of leverage personalized shopping as well, because the data that we need to ingest from the previous transaction, historical shopping that they had, again, we can document them, make them well organized for the next time, for even recommendation models that we can generate on top of LLMs. So still I'm trying to kind of prepare the scene, giving more backgrounds that what we have on LLM, what are the benefits of LLM. So we have to, on the other hand, we have to be sure that we shouldn't have models or LLM models that they are kind of super biased. Because again, these days we know that there are LLMs that are especially designed and defined for one special business, to just react for that or just respond back to that. For example, only the training data set is regarding finance, nothing else. On those special training data set, easily LLM can be biased, because it doesn't have the general knowledge of other sciences, and it can again simulate and faking the science or knowledge and going to biases by the questions that you have. On the other hand, we have to again be sure that privacy is the first thing. Because if you don't encrypt the information that you have on the training data set, and even when you don't encrypt the transaction between LLMs and the models that you have, easily those could be a kind of a headache for the organization as well. We can lose the privacy information and sensitive information on that. We know that even in the organization these days, most of the kind of employees kind of using these LLMs, but they are sending the sensitive information of organization to the cloud-based LLMs that can be harmful for that business as well. So we can follow different actually AI rules that we have. I brought a couple of them, and kind of having best practices to stay legal, stay safe when we are using the large language models. This is the big picture that we have today as a very simple scaled LLM application. When I'm saying LLM application, what does it mean? Suppose that I have a very simple summarizing task that I want to use OpenAI models to make that summarization for me. But through a kind of a best practice of different resources that we have to have, for example, on the cloud computing, not instead of having on premises, it could be kind of easily having a load balancer on top of that, and be sure that it is reliable to use even in the large language models for the enterprises as well. So suppose you are here as a coder, as a kind of data scientist, data engineer, and you want to have a code that be available to the public to use it, and in the core it has an LLM service inside of that. So we are here. The code that we want to kind of deploy today or develop today would be on this container. We will use a cloud container repository to keep that cloud code, and then we will use a cloud container service to kind of having a public application on top of that. In between, we need to use the LLM orchestrate to do whatever task that we have. It could be summarization, it could be translation, it could be extending a text, or kind of whatever request that an LLM can respond back. In between, I brought the secret manager as well and load balancer to make it more scaled. So this is a fully packed design package that you can use on any organizational or enterprise LLM application. So I will start with the secret manager. Here on this big picture, you can see that it is here, but why I started here, it has a message. It means that first be sure that you are not hard coding any part of your credential that you're using. So my suggestion is use one of the cloud secret managers. The tech stack that I have here they're all on AWS, but you can use Google Cloud, you can use Microsoft Azure, or whatever kind of cloud services that you have. So use a cloud secret manager. Always securely store your API key, credential, and sensitive data. There shouldn't be any hard-coded secrets on your code anymore when you are make it actually scalable. Automated rotation. When you use a secret manager, suppose I'm using AWS, you can have the automated rotation. It means that regularly when you forget to change your password, change your credential to kind of keep the environment and the tech stack that you have securely, this does for you automatically. You can easily, when your application is scaled, change the permissions, access controls, and auditing that you need without touching anything, because everything is controlled on a cloud-based service. So you can work across cloud provider, use any of these, AWS Secret Manager, Azure Key Vault, Google Secret Manager, whatever that you decide. Don't forget that professional tip. If your credentials on your code, they're probably on GitHub now. So I talked about this part, and I show what is the benefits of having Secret Manager, and hands-on, I want to show you on the code as well. So I'll start to kind of show what's going on here. It is a very simple application, it has one main app.py kind of file that would be deployed to the Docker and the next level, but that's the main application or start point that we have. On that app.py, I have a Docker file that I'll show when it comes to that how we can have a very simple Docker file for the deployment. Then there is a get prediction module and get secret module. Those are CSVs that I just saved my credentials that I use, for example, to connect to OpenAI, connect to AWS, all those credentials that I created. And there is a requirement, the TXT, that it keeps all the packages that you need to run this package. So we were talking about Secret Manager, and I created this module separately. It is so simple. What it does is just we are using a client object to connect to AWS, and instead of hard coding our OpenAI credential that we want to connect to LLM, we just keep it on AWS Secret Manager, and we can call it here whenever we want. So this is the AWS console. I'm using this region. So if you wanted to kind of code this simple piece of code that I had, you had to kind of prepare a couple of things. First of all, you have to go to the IAM part and create a user for your application that instead of your root secret, your root username that you have, this kind of cloud user that you assigned here used on your app. Then again, it helps you to, whenever you are scaling and changing the permission, easily use that. I always kind of encourage everyone, never use your root username and password whenever you want to connect to the cloud as well. So I just define this LLM user and give them enough permission that it needs. And if you search for the secret managers on AWS Cloud AWS, you have the secrets, you can define your secret. I defined this OpenAI secret here, and now you can see that you have a key, you have a secret name, and you have a secret ARN. Secret ARN is used between the resources of AWS when you want to connect to that. And if I show you the info, secret value is here. If I retrieve it, it will show to everyone. But I can keep it here simple and safe. The other thing is you need to have access to OpenAI platform as well. And when you go to your profile, you can have your API key, and you have to first define, I defined the Untapped Energy API key for today demo, and the secret is here. So all I'm doing is I'm avoiding just put this code, not hard coded on the simple piece of code that I have. So it's here. I kind of copied this API key and place it on this secret manager to the value of that. But when I run this get secret module pi, you can see that I kind of commented out to just see that if my secret that I saved on the cloud service works or not. So I just run this as a new terminal. I call Python and say I want to get secret module. And you can see that my secret module is showing here. So at least I know that this part of my code is working. So from now on, we have the secret manager, and any other credentials that we will have, we will save it here on the secret manager, and we can call it easily. The next part is the container part. Again, don't forget the big picture. We finished this part. Now we want to go to the container. We want to make sure that how to create a simple Docker file that would be your container. But why we have to have a container? Why we have to have a Docker? So first of all, we can easily run our LLM consistently across different environments. You are fully kind of can be reliable on the Docker file that you are creating to be sure that all the packages, all the dependencies that you need is on your container whenever you deploy. It is lightweight and portable. The scalability is super easy. You can create as much as instances that you want based on the Docker file that you have. You can have your version control on your AI models that you have and roll back and kind of upgrade to any versions of your code to keep it on different Docker files. You can isolate the dependencies, no conflict, no chaos, and just smooth deployment. The pro tip is if your AI is too big to run, just put it in a container, because container can kind of expand as what you want. So just quickly going through the simplest Docker file that we can create here. So first of all, you are kind of mentioning which version of Python you need. So easily you can change it. I requested the slim one because I didn't want to have all the packages default by Python. Then I kind of suppose that my work directory is that /app. When I want to deploy it, I will get the updates of the kind of all the build essentials, softwares, and packages that I need. As I want to easily kind of publish it as a web app, and I don't want to have a coding, I'm just using the Streamlit and getting the clone of that example of the Streamlit kind of Git. I will show you a Streamlit here as well. Then I'm asking that the requirements that new, that I frozen, make it frozen by the last kind of changes of the code that I had, all the packages. Now I've added that I have two modules, should be beside on the app, the main application that I have. Then I will run the pip3 install to install all the requirements on the Docker file that I have. It would be on the container. And health checking the kind of the port that I'm preparing. This port is kind of just your preference, whatever port that you want. I put it as an 8501. And then it's done. You just need to ask when the Docker is up and running, you want to know that, you want to kind of run this piece of parameter. You can say that I want to Streamlit run the app.py with these ports, and done. So you don't know that how beneficial this Docker file would be for a data scientist that every day has exposed to different version of Python, different version of libraries, and easily they can deploy it to the container service that you have. Now the Docker file is ready. We want a repository to keep our versions of the Docker files that we have. The repository is just a place that you can put your whatever Docker file that you have that you've deployed with your application inside that. And then whenever you want, you can get one of the versions and branches and deploy it and use it very quickly. We are talking about make everything scalable. So why we are using the container repository? It makes it centralized storage for all your Docker image. Why I am using here AWS Elastic Container Registry? Because it's secure, scalable, and built-in AWS workload. It's easy deployment with ECS. I will show you. It has a versioning and rollbacks, manage all the permissions and access control with that. And your AI model deserves a safe home. Don't let it live on your laptop forever. So where is container service? If I get back to AWS, so now we know that what is IAM on the AWS and what is the secret manager. But now I am talking about Elastic Container Registry. It's another name of container repository. So as you can see on the repositories, whenever you want to create, just need to click on this create repository. You can make it public, private, who can use it, and if it is immutable or non-mutable. So if you can see that, now I have a Docker image that I created on my end. If I show you, if I bring, so you can see that with that Docker file that I created, first I built it 22 hours ago, and then I made an image on top of that. Whenever you have a Docker, is like a blueprint for you, that how you want to have the images of your container. Then you build it and push it to your images locally, and then you can push it to the ECS or Elastic Container Service that keeps all your repositories. So the repositories here, you can see that the size of the whole application or the whole kind of infrastructure that you need is just 500 megabyte, and it has all the information inside as well. We've done this part, the container and cloud container repository. We are going to finish step by step. So the next step is cloud container service. And to be honest, these guys as well here, LLM service and LLM orchestrate. We can go first to this one or that one, doesn't matter. So before this, kind of talking about the horizontal or vertical scaling, I want to bring the code again. So the Docker file is ready, get secret module is working as well. I want to see that if I can have a simple summarization task with a simple piece of code that I'm using these packages. LangChain is one of the best orchestrator of whichever or whatever LLM model that you want to talk to, because it removes all the hassles that you need to connect to that for example, OpenAI or other, for example, Hugging Face or whatever kind of models that you have. And it's easy, just do for example, here I use the LLM of OpenAI. It's just one piece of code. You have access to the OpenAI, and then you can send the document that you have and get the summary out of that. It's just 3 lines of code. So I copied that here, send it as a parameter of this function here. My function is just a prediction pipeline. It gets a text and create the summary. If I just say that I want to run get prediction module and run it, let's see how it goes. So as I turn on the verbose on, so what I'm doing is I'm asking LangChain to do all the piece of codes for me and kind of running all the modules of connecting to OpenAI and then sending the whole text, make it as a map reduce. For example, instead of having a big text for OpenAI, we just make it chunk and then send it to the model and then getting back to that. I want to quickly show you something here as well, that on the OpenAI platform, we just sent a request. So there is a usage tab that now it said that I used $0.0, 1 cent used out of LLM to just kind of do this summarization. So it's an online kind of platform that you can see your usage, you can limit it, you have budget. I don't have that much budget there. You cannot run it a lot. It's just $4 there. So, but the good thing is you can kind of monitor how much you are spending on this project. So this paragraph changed to summary of this one. But now it is not a very good interface for me to kind of use this using the verbose of whatever commands in between the LangChain going on. I want to use another kind of stack. And what is that? I just make this commented out, and even this print commented out as well, because I'm using this function as a module for the APP, the main APP actually, main file, main application that I have here, main Python file. You can see that how small it is. So what I've done is only I imported my prediction pipeline from the get prediction module, that it has all the thing. It has a secret manager in itself as well. And I'm using Streamlit package, a Streamlit library that quickly creates for us a web application without knowing anything about web designing or web application. You can see that I just need a text area and then put enter text to summarize, and I need a button there that it generates summary. And if both of them are true, now I need to call my prediction pipeline and get the summary out of that. So how we can run this is very easy. So when you run that, boom, your web application is ready with just 3 lines of code. And we can bring that big paragraph here and just paste it here. And when I click this, you can see it says running. It hurts me again because it kind of used my kind of credit on the OpenAI. But now I have a summary here. The authors have developed an atlas of neural networks of whatever, blah, 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 blah. So the application is ready on my local system. It's not deployed on the clouds yet. All the tech stack that I needed is here. I have the Docker file, I have the modules that I need, I have the APP file with the Streamlit on that, and ready to be kind of deployed. So container registry was just a repository of the image that we had. Now it's the time that we use elastic container service, because registry was the repository, service the way that you can run your kind of Docker file, your images, your virtual machine, whatever that you have, and kind of get the application run out of that. So I'll go to the elastic container service, and you can see that first we need to define our cluster here. So the cluster, I named it again for this demo, cluster overview. Here is that you can, when you want to have your system scaled, your application scaled, here, this is where you have to decide to have it horizontal scaling or vertical scaling. So what are the differences between horizontal or vertical? I'll start with the vertical. Vertical means that you pay more to have more resources on one service. It means that if your application is slow, you'll add more memory or add more kind of whatever resource that you need. Might be processor, might be memory, or whatever. It works well with the high performance computing and database, because one database needs the resources it needs. It cannot be kind of out of that resource. But it will be limited by the max instance size and potential downtime that we have. The main issue with the vertical scaling, it means that if that service goes down, everything goes down. It's down actually. So we'll use the EC2 instance resizing on that it decides that when it needs more resources, it automatically scale up the system. And we have RDS scaling and Lambda memory tuning as well. But I'm not fan of this vertical scaling. I'm more fan of horizontal scaling. It is better to have more systems ready than have one big system. Having small systems ready is better than have one integrated big system. So better for distributed workloads, for example, AI reference and web apps. This means that you can have, even with the horizontal scaling, you can have one kind of container or one kind of service to just do the web app for you, and the other one just connecting to the OpenAI and do the AI kind of inference for you. It improves the fault tolerance. If one fails, others keep running. Again, on the AWS services, you can auto-scaling groups. You can define auto-scaling groups, ECS, and all the load balancers that you need. The pro tip is, if you doubt, you just scale horizontally first. If it didn't work, get back to the vertical one. Now, when you have your cluster ready, just you need to create a new task to run that actually application that you've created and deploy it for you. Before running the task is running, before showing you that on the cloud now it's running and works, let's click on the new task here. This is all the kind of configuration that you need when you want to make it kind of scaled actually. What I used was just using a launch type because I just wanted to test it, and I'm using the launch type of Fargate. The good thing about Fargate is it is serverless kind of. It is not turned on up and running unless you have a request on that. So you pay less with the Fargate, but for the big systems that always they have requests, there's no gap between the requests, you shouldn't use this Fargate, because at the end of the day, more payment you have for the Fargate. You have to pay more. But you can have reserved services with EC2 that say, I always need this, for example, portion of memory. I always need kind of these resources. So at the end of the day, you pay less because you have more requests answered. Then you can have it, again, in the deployment, you can define as a task that one-time launching of the app, or it is a service based on the request or criteria you want to bring up the deployment that you have. How many desired tasks, the number of tasks to launch, it is again another type of scaling. But if I go to the networking here, it's important to know that how many kind of NCs that you have, network cards that you want to prepare, the volume of things that you have here. Last thing, if I change it to service here, you can see that this is the way that you can do the kind of health check as well. For example, you can have a grace period check of every 30 seconds. check my first cluster. If that failed, I want another cluster to be up and running to kind of serve the requests that we have. So it's kind of the horizontal way of making it scale. And we have the public IP address for this. You can just open it. So this time it is not on my local machine. It is on AWS. It is on the task of the ECS. And if we put again the big paragraph they have here, let's see if it works or not. It's running. It hit this part again. And now you can see that the summary is ready. And it is on the cloud. So if we go back to the big picture, we've done all these parts all together today. So we started with the code, very small piece of code samples that you can kind of extend it for your need. We prepared the container on the Docker file. We pushed the container file or the Docker file that we had to the repository of the kind of cloud container repository that we have on the AWS. And then on the cloud container service, we used to deploy the cloud service, the cloud repository that we saved here, an instance of that, and bring it up as a task. And now the public app is ready. And if we wanted to select the service to have a load balancer, we could kind of having the load balancer here as well. But now I want to just, as the kind of the preparation of the application is ready, now I just want to know that we can discuss together today as well that what is the future of the LLMs? Is it only about text? What is the next for the LLMs? Wouldn't be even only to be on the text. We can have the images, we can have the videos, we can have whatever combining text and images or videos or frequencies or even sentiment on top of that. So as we know, with the GPT-4o and the reasoning one, you can even upload the text or upload an image that it has a text inside and then ask about the text as well. So it's going very fast to have all the kind of multi-model, like a human, to have different channels to ingest what you want to ask. It wouldn't be only on the text. I'm sure that in less than a year or 2 years, they will add kind of might be taste to that, frequency of the listening better than even the human, or even, for example, they can have the feeling of touch to that what it is touching now, because everything can be a model for the LLM in the future. Your AI is in your pocket now. You can have all the applications of GPT, ChatGPT, DeepSeek, or whatever kind of LLMs that we have. It's going to be smaller and efficient models on devices. And to be honest, I'm sure that the next step would be democratizing of AI as well, having everyone all around the world having access to that. Because even nowadays, there are countries, there are kind of people that still don't have access to these services and they got banned.